Okay, so we're going to continue our discussion of advanced NetLogo programming concepts. And in this case, we're going to start, again, using anonymous procedures. We're going to talk about map and reduce. And map and reduce are similar and related to each other. Map takes a reporter and a list and applies that reporter to all elements of the list. Kind of like the way of works for agent sets, map's going to do the same thing for lists, right? And so, for instance, in this case, we're doing map val, which is our anonymous procedure, round val 1000, val divided by 1000 to this list, right? So we have, this is the kind of reporter, right, which is this anonymous procedure we created, which takes a value, divides it by 1000, and rounds it, right? And we're going to apply it to this, and we're going to see what the results are, right? And it's going to generate company revenue in the thousands. So for this list, it should generate 34, 12, 75. There might be 76, right? Things like that, right? And then, and this one actually is the same thing, but now we have two inputs, right? So we can give multiple lists. It doesn't have to be a list. So we're going to give it a revenue and an emp, and this is going to stand for number of employees. And we're going to do round rev divided by emp. So this is the revenue per employee divided by 1000, right? And so we're going to give it the revenues of the firms, right? And then the number of employees of each of the firms. And the idea here is that, you know, we have a bunch of we have a list of revenues from various companies, and we want to generate what the company revenue per employee is in thousands. And in fact, we already saw an example of map in the overall bar problem, right? Where we did map weight of week onto the function weight times week, and then we gave it the weights from the strategy and the history, which is the past attendances, right? And so that automatically generated like the multiplication, a list of these multiplied, and then we put sum in front of it to sum it all up, right? And that kind of the way to think of that's applying the linear model to the actual data, right? So let me, this might be hard to understand the abstract. Let me show you an example in NetLogo. Okay, so now I have this sample example up, and the code is very simple. Turtles, which are the firms, right, are going to own revenue and number of employees, and then we're going to maintain these lists, which is the revenue list of all the firms, and the number in the employee list, which is the number of employees. And then we're going to create 5 firms. The revenue is going to be random between 0 and 10,000. The number of employees is going to be random between 0 and 100 plus 1, just to make sure we have at least 1. Just located randomly. And the combined list, right, which is this kind of combined element, is going to have, it's just going to be the revenue and the number of employees of all turtles, and then we're going to set the R list. So once we have this combined list, we can then set the revenue list to the first element of the combined list. So what that's going to do is it's going to pull off each of the sub lists. So this is a list of lists is what this is going to generate. I can show you. Let me see. I hit setup, and then I hit, actually probably the easiest way to do it is to just do print combined list, which I had commented in there. So I'm going to hit setup, right, and you can see the combined list right there. Right now, so you might ask, well, why didn't I just do revenue of turtles as R list and employees of turtles as E list? Well, the problem is that because of is generating things randomly, they're not going to be in the same order. So what I did was instead I generated them once in a random order, putting both the revenue and the number of employees for each firm next to each other, and now I can pull them off, right? And so I have this list of lists, right? And what this map is going to do is go to each of those sub lists and pull off the first element and set that to the revenue, and then the second one is going to take the but first, which returns everything after the first. That's a cool little command. So but first 615172, right, is going to return the list of 72. So in order to get the number 72, I actually have to take the first element of that list, right? And so that's what that's doing. So I'm using map here to essentially create this revenue list and this employee list, right? And then I'm going to do that again throughout the code as it runs when I increase the number of revenues, etc. Right? And so we can set up and we can go, right? And we keep generating. If you look at it, right, we can keep generating these lists of employees and revenues, right? Now these commands are actually a little bit more complex, so let's talk about what they're doing in the reporters, and they're using map again. So here we're actually just, it's kind of similar to the way we did in the code with the R list. We're just saying, hey, give me the revenue, divide it by 1,000 and round it. So this is like the example I showed in the slides, right? And we're going to map that onto the revenue of all turtles, right? And then we're going to sort it so it's from the highest to the lowest, right? So now we have the list of all the revenues. And then let's say we want to calculate revenue per employee, right? We can do revenue and emp round. So we're going to take the revenue, divide by the number of employees, divide by, and this again what I showed in the slides, right? Round that, and we're going to do it on the revenue list and the employee list that we had from before, right? So one small note, like this is actually going to generate let me stop it. This is going to generate those in a somewhat random order every single time. The company revenues list is always going to be sorted by the company that has the maximum revenue. So that's actually 4 quick examples of how to use map. Hope it makes a little bit more sense now. It's a very powerful tool. It can make taking a whole bunch of code and making it really simple, really easy, right? The L for all bar problem, I think, is a great example of that, where like you have all this, I got all these variables, I got to multiply by these. And if you did it without the map, it would be very difficult to do. You'd have to like figure out how to loop through it and multiply them correctly. And map just says, take this list, multiply it piecewise by this list, sum it all up, and we're done, right? And that's much easier to do. So let me go and talk about reduce, which is kind of a nice complement to map, in just a second. So whereas map took a reporter and applied it to the list individually, item by item by item, and just output everything into a new list, reduce is going to take that list and apply it to every operator, assuming that they, in order from left to right, kind of continually aggregating them, right? So for instance, in this case, we're doing reduce plus all these numbers. Essentially, it's the same as doing a sum of that list, right? So it's going to take 35 and add it to 104, take the result and add it to 54, take the result and add it to 28, take the result and add it to 35. And then by dividing by 5, we're essentially, this is now computing the average of that list. Right? And of course, you can do it with 2 inputs, right? So we can again use this anonymous function to do input 1, input 2, if else value of input 2 equals 35, then do input 1 plus 1, otherwise input 1. And so we create our list, but we put a 0 on the end to start the counter because that's going to be input 1, right? And we're going to do 0, and then we're going to check to see if input 2 equals 35. If it does, then we're going to increment. So we're going to increment that to 1. And now we're going to go to the next one for input 2. And then input 1 is always the sum of the result of the input 1 calculation. So it's going to be 1, and now 104 isn't, so it's going to be 1, and 54 isn't, so it's going to be 1, 28 isn't, so it's going to be 1. And then 35 comes along again, and it's going to do input 1 plus 1 and get 2. So this essentially counts the occurrences of the number of occurrences of the number 35, right? And reduce is a cool way to kind of take a bunch of data and kind of collapse it quickly if you use it properly. So give me a second, I'll bring up the NetLogo model and we'll talk about it there. Okay, so we're back with that first NetLogo model, the one we were looking at before, which has the firms and does the calculation of revenue per firm and average revenue per firm. And we're gonna look at the reduce command. So in this case, we have the reduce command, which is the simple example where it's just summing up the revenue of the turtles, right? So revenue of turtles is going to return. Now, we could literally have just put sum here, and we could in fact put mean or average there to get the average of all of them. But we're going to do it a little bit more manually just to show off reduce. So reduce plus revenue of turtles, divide by the count of turtles. That's going to generate our average revenue, right? Over time for all of the firms. And you could double check that by going through the company revenues and seeing if they add up, right? And then let's say if we just want to count the number of firms that have over $10,000 in revenue, right? Well, then we can use that code that we described before where we are looking at whether or not something is equal to 35, right? So in this case, we're going to do reduce count and revenue, and we're going to use if-else value, which is kind of a little bit complex, but it says, basically if-else value says if something is true, then return this value, otherwise return this value, right? So if the revenue is greater than 10,000, return the count plus 1, otherwise return count. And we're going to process that on the revenue list, which we created using the map function, except for we're going to put a 0 on the beginning of it to start as the counter, right? So 0, 0 plus 1, 0, and so forth, right? And so this is going to count the number of firms with revenue over 10,000. And sure enough, if you look at the firms' revenues, it says they're all over 10,000. Here they clearly are because it's in the 10,000s, or in thousands already, right? So, reduce is kind of a cool way to take a bunch of elements and kind of combine them in some meaningful way to produce your results. And of course, all of this, both map, reduce, run result, they're all powered essentially by anonymous functions. You don't always have to use anonymous functions, but they do help make this code run a little bit faster, and you can have your nice compact code. Anyways, I hope you like this little quick intro to some of the more complex NetLogo programming examples. I do think that these are useful in general, these kinds of functions, even if you're not using NetLogo, to find something similar to these, because they allow you to take a list of things and kind of manipulate them using code that you're creating dynamically on the fly. And I think that's a very powerful technique and tool to take advantage of in your agent-based modeling.